All right. Okay. So guys, 7.3 is hypothesis testing for the mean when we don't know the population standard deviation. Instead of us knowing the population standard deviation, guys, we're going to know the sample standard deviation, okay? Let's see. And this is when we're going to be using like the t-distribution. So guys, if you remember, we talked about like inverse t and stuff like that, and we have to do degrees of freedom, all that kind of business, okay? So let's see if we can figure some of this stuff out. Okay, so how do we find the critical values for a t-distribution? We are going to specify the level of significance, alpha. We're going to determine or decide whether the test is a left test, right-tailed, or two-tailed test. Let me make sure I'm recording. Yeah, we're good. Okay. Oh, what's that? Is that me? All right, let's see. All right, let's see. So guys, we're going to figure out if it's a left tail, right tail, two tail test. We can find critical values using that t table that we used, or guys, we also used the inverse t function the other day in our calculators. Okay, so let's take a look what it says here. When the hypothesis test is a left tail test, we're going to use one tail with a negative sign. If it's a right tail test, we use column A with a positive sign. I'll explain this part in a minute. And two tails, we use the two tails, a column with both negative and positive. Okay, so I'm going to show you how to do this two ways. Let me see, let me grab this real quick like. And do I have my, where's my tables? Here we go. Tables. Okay, not this one here, but I'm going to look for the T. Here we go. Okie dokie. All right. So two ways we can do this problem. Look what it says for the first problem, guys. It says, find the critical value T0 for a left tail test given that alpha is 0.05 and n is equal to 21. Okay. So left tail test. Okay. I'm looking for a value, guys, that we're going to call T0. Okay. It tells me that my alpha is 0.05 and my degrees freedom is, or n is 21, okay? Guys, if I use the chart, okay, let's see. Let me come back over here. So look what it says. If it's a left tail test, use one tail A, column with a negative sign. So I come back over here. All right, left tail, what was our alpha in this case? What was the alpha number? 0.05, okay. So I'm looking for alpha 0.05. You see it right here? Alpha is 0.05. What was our, in this case, what was our n? 21. Okay, guys, if n is 21, do you remember that the degrees of freedom is always going to be n minus 1? So it'd be 21 minus 1, which is equal to what? 20? Okay, so I'm going to come back over here to my table. Okay, I'm going to go to when alpha was 0.5. I'm going to go to degrees freedom of 20. Look at the value that we have right here. What is that number? 1.725? Okay, now guys, it says we're going to write it, but we're going to write it with what kind of a sign? Negative sign, right? So right here, I'm going to put negative 725? Okay, so guys, one way you can do it, you can use the table. The other way you can do it, you can use your calculator, okay? So guys, on your calculator, what you're going to do, with the exception of those of you who have the 83s, if you have an 84, guys, you're going to go to second vars, okay? And right here under inverse norm, you're probably going to have one that says inverse t, right? So you're going to hit an inverse t. On my calculator, guys, I had to program this thing in. Okay, so let's see. The area to the left, what was the area? What's the alpha this way? 0.05. 0.05. Okay. All right, enter, right? And degrees of freedom, what was the degrees freedom in this case? 20, so you're going to hit 20, and you should hit enter, and let's see if we come up with the same number. Are we? Negative 1.725? Okay, what do you like better, the chart or the calculator? Okay, use the calculator, right? You like the chart, use the chart. But you see my point? You can do it one of two ways, right? All right, so guys, I'm going to keep using my calculator because fussy, right? Much faster and everything. All right, so there's our left tail test. Now, let's do it for the right tail test. So the right tail test, look at my alpha here. It's 0.10, right? So that means that the area over here is 0.10, right? Guys, what would my degrees of freedom this way be? But hold on, remember my n is 9. What's my degrees freedom though? 8, right? Why is it 8? Because it's always what? 1. It's always whatever my n is minus 1, right? Okay. Now guys, remember when I told you when we're using the inverse norm or whether we're using the inverse t, my calculator in my table always tells me the area of which way? To the left. So my question to you, if the area to the right is 0.10, what would the area this way be? 0.90. There you go. Okay, so guys, when we use our inverse t, right? Okay, when I go to my inverse t, the area to my left is going to be 0.90. Okay. And what do we say our degrees freedom was? 8. Okay, I'm going to hit enter. And let's see if we all come up with the same number. Are you coming up with 1 point, would you say 40? 1.40? Or actually, you know what, guys? I'm sorry. On the t values, let's go to 3 decimal places, okay? Let's actually do 3 decimal places. And the only reason I want to do 3 is because if I look at my table, how many did they have here? They got 3, okay. So when we did that, what number did we come up with if we go to 3? 1.397, okay. So here's our t value, right? Our t0, 1.397. Okay. That's my answer, right? That's my critical value, T0. Does that make sense, though, how we did it? Yeah, and remember, that's right, because remember, my calculator always tells me the area to the left. That's right, to the left, right? So that's why I had to use the 0.90, right? Okay. Now, guys, take a look at the next one. It says, find the critical values for, and look, it gives me 2 of them, and it's already telling me one of them is going to be what? And the other one's going to be positive, right? Okay, for a 2-tailed test, given that alpha is 0.10. So guys, again, just a quick reminder, what this means here, if alpha, that's right, is 0.10, then that means that each of these here, wouldn't that be 0.05 and 0.05? Okay. So guys, remember, my calculator always tells me the area which way again? To the left. So what's the area to the left right here? 0.05, right? Okay, so let's grab our calculator, clear it out. Okay, we're going to go to inverse t. Okay, so there to the left is 0.05. Okay, guys, what is our degrees freedom in this case? 25, because our n is what number? 26, so we always got to subtract 1. So 25, hit enter, and we should come up with the -1 at first. Remember, we're going to go to 3 decimal places, guys, so -1.708. Okay, good. I'm not sure that's what y'all said, but I'm going to say that's what y'all said. -1.70. Yes. 708. And the other one was just the positive of that, right? And we found our critical values. So far, so good? Okay. All right. So let me scooch down here. Okay, guys, one thing I want you to notice here. Look at this formula right here. Doesn't that formula look real similar to the one we've been using? Right? We're still taking our x bar minus our mu. The only part, guys, that's different here is that instead of sigma, what letter am I using here? I'm using the S because we're going to have the sample standard deviation, okay? All right. So, guys, the way we're going to do this here, there's a couple of things that we got to know. So, number 1, it says verify that the population standard deviation is not known. In these problems, guys, the population standard deviation won't be known. Sample is random. Either population is normally distributed or we have at least 30 or not more samples, okay? State the claim mathematically and verbally. Identify the null and alternative hypothesis. This is our HO and our HA. Right? Specify the level of significance. Let's find our alpha. Let's find our degrees freedom. Remember, it's always going to be n minus 1. Guys, critical values, which is what we just found, we can either use the table, or what's the function we use on our calculator? Inverse what? Inverse t, right? Okay. Determine the rejection regions, find a standardized test statistic and sketch the sampling distribution, which is RT, and then make a decision whether or not to reject or fail to reject the null hypothesis. And let's see if we can do this problem here. All right. So problem number 4 says a used car dealer says that the mean price of a 2-year-old sedan is at least $20,500. Okay. So guys, I'm going to stop right here. I'm going to read this sentence, the first line, and let's see if we can figure out what are they telling me. So number 1, they're talking about the mean what? Okay, so everybody agree this is the symbol we use for the mean price? The mean? Okay. What does it mean to say at least 20,500? At least 20,500 means it's going to be 20,500 or what? Or more, right? Okay. So 20,500 or more. Does everybody agree that that is our claim? Because that's what they're saying, right? Okay, so guys, what would the complement of saying something is greater than or equal to 20,500 be? Something is less than 20,500. Okay. So now I got this part right here. Okay. Guys, which one of those is my HO and which one of those is my HA? The claim is the HO, and this is our HA. Okay. All right. Now that we have that part, let's write down a couple of other pieces of information. Let's see what we know. Okay. A sample of 14. Everybody agree that means that my n is equal to 14? Okay. Has a mean price of 19,850. What's that number? That's my x bar. Okay. So 19,850. Okay. And a standard deviation of 1,084. Guys, before we were using the sigma, okay, this one here is going to be for my S. And the reason why I know that's for my S is because in the problems before it said the population standard deviation. The population standard deviation is the O with a little hat, right? If it just says it's the standard deviation, they're referring to the sample standard deviation, okay? And that's what we call the S, all right? Let's see. Now, guys, in the formula that we have right here, I'm just going to write that part down. Let's see if we can find our t value, okay? So the t value is equal to, everybody agree, x bar minus mu divided by s divided by the square root of n? Okay. So guys, I'm just writing mine in parentheses, and the reason why I'm writing mine with the parentheses is just so that you know when you're doing this on your calculator, this is what you're going to end up typing in, okay? All right, let's see. What's our x bar in this case? 19,850, right? So 19,850 minus, what is our mu? 20,500, very good, okay. Divided by, what is my s? 1084 divided by the square root of our n, which was 14, okay? So, grab my calculator, where is it? Here we go. Okay. So, first thing, turn it on. Okay. Guys, first thing, everybody agree, 19,850 minus the 20,500? Okay, negative 650? Okay, divided by, remember what we're going to do, guys. Parentheses, what number? 1084, okay. Divided by, again, second square root, 14. Okay, and I know in my calculator I got to close them up twice. Some of you, yours doesn't do that, but I got to do it in mine. Anywho, hit enter. Guys, I'm going to write down 3 numbers here. I'm going to go, 3 decimal places. So everybody agree, negative 2.244? Okay, so negative 2.244. Okay. this is my t value, right? Sorry, I had a little brain goes out there. Okay, all right. So guys, now what I need to figure out: left tail, right tail, two tail. Do you remember which is the one that I look at? The HA. Let's take a look at our HA. So which way is our test going to be? Somebody said it? Left tail test, right? Okay. So guys, remember what I'm going to do now. I'm going to come back over here, right? So here's my alpha, right? It's telling me that my alpha is 0.05. So that means that the area inside here is 0.05. What I need to do is I need to find that little t value when the area to the left was what area again? But what was the area to the left? 0.05. Okay, so guys, let's not forget how we find that value, right? I'm going to come back to my calculator, okay? I'm going to turn it on. I'm going to clear everything out. On your calculator, guys, you're going to go second vars, and you're going to go down to inverse t, okay? On my calculator, I got to do my inverse t function, okay? What did we say the area to the left was? 0.05, right? Okay. Enter. What was our degrees of freedom? Does anybody remember? What was my n number in this case? N was 14, so my degrees of freedom has to be -1, which would be 13. Okay, we're going to hit enter. We're going to let it do what it's got to do. Okay, if I go to 3 decimal places, guys, -1.771. Okay, so right here, this number is -1.771. Okay, so I'm going to try to zoom in a little bit, guys, just so we can see a little bit better. And to remind you also of what this is telling me. Okay, remember, guys, this area here is my fail to reject. This area here is my reject. My question to you, look at the t-value that we came up with, right? This was the t-value we came up with. That -2.244, would that be to the left of this number, or would it be to the right of this number? To the left, right? Wouldn't it be further over here? -2.244. Okay, so are we in the rejection zone? Okay, so now what we're going to do, we're going to reject the null hypothesis, right? Okay. All right, now guys, I'm sorry. Yeah, it was a -177. But we're still, yeah, I'm sorry. I might have erased it when I did that. Yeah, it's right here. Yeah, no, that was my bad. That's right. -1.77, we came up with a -2.244. And because we fell in the area to the left of it, which is the rejection area, that's why we said we had to reject the null. Does that make sense? Okay, now guys, when I get to this part right here, let me see if I still have this close out open. Do I not? Where did I put it? Yeah, let me come over here. Where's my cheat sheet? I think that's what I called it. Here we go. Here's my cheat sheet. Okay. All right, so guys, whoa, buddy. But which H? Okay. All right, so our claim was our claim was our HO, right? And because we're rejecting it, what are we going to do now? Yeah, so the claim is HO, and we rejected it. There is enough evidence to reject the claim? Okay, so I'm going to write that right here. There is enough evidence, sorry, my handwriting's horrible, to do what? To reject the claim. Boom. Guys, what I want to point out about this problem that we just did and the ones we did earlier, the only thing that's different here is that I don't have the sigma, I have the S. So instead of me finding the Z value, I'm finding the T value, right? And so the calculation of what we did right here, this calculation is the same calculation we've been doing. It's just that instead of using a sigma, we use the letter S. But in terms of like how I'm entering everything in my calculator, I'm doing it exactly the same way, right? The only part that was slightly different was how we came up with that number right there, right? Instead of using my inverse norm, I'm having to use my inverse t, right? And not only do I need to know the area to the left, but I also have to know my degrees freedom. But other than that, the calculation is going to be exactly the same, okay? The inverse t is to find my TO, right? Right, and didn't we do that right here? See where it says to find the critical values right here? That's why I put the little inverse t. That's how we found our TO, right? So let me put it right here, TO. I'm sorry, Fred, you had a question?
No, I mean, is everything up to now, it's sort of within, you still have to take the point and get another point.
So the thing about it this way, you're finding the point here using all the information we have, and then just using the alpha, that's how you find your critical value, right? Your TO. Okay. Well, that's what we got to figure out. Is it going to be a left tail test, right tail test, or two tail test? And remember, the way I know that is by looking at my ha, right? Does that make sense? Okay, so look, guys, let's do one more, because I think there's one more on the next page here. Let's see if we can figure this thing out, okay? All right, let's find our ha. Okay, first thing I'm going to do, I'm going to read the first sentence. An industrial company claims that the mean pH level of water in a nearby river is 6.8. Okay, so guys, what symbol do we use to describe the mean? The mu, right? The funny looking U is equal to 6.8. That's our claim, isn't it? Okay, there's my claim to fame. All right, now, what is the opposite of saying something is equal to 6.8? It's not equal to 6.8. Okay. All right, so I'm going to put this stuff in a box right here, okay? Now, guys, which one is my HO and which one is my HA? The top is the HO. The bottom is my HA, okay? All right, so guys, I want to mention this because I know Jackie right now was getting to this part. Okay, guys, remember, how do I know what's going to be left tail, right tail, two tail? I got to look at which one? The HA. Okay, so if it's saying it's not equal to, what kind of test? Two tail test. Okay, so let's do this. Let's find those critical values first. Okay, do you see how the alpha is 0.05? Okay, but guys, because this is going to be a two-tail test, what am I going to do with that alpha number first? Divide it by 2, 0.025? Okay, so 0.025. Now guys, remember, we're going to get two values. One of them is going to be negative and the other one's going to be positive, right? Okay, so let's see what else. Before we find the TO, there's one other thing we're going to need. The other thing we need is we need to find our degrees freedom, so we have to know what our N is. What is the N? How many samples did they take here? 39. Boom. Okay, so if my N is 39, what's my degrees freedom? 38. Okay, so guys, let's find our TO value, okay? Let's do that first. Turn it on, bring it over here. Okay, I'm going to do my inverse T. Okay, what is my area to the left? 0.025, right? Oh, there we go. All right, what is our degrees freedom? 38. Okay. We should be coming up with a negative number. Guys, we're going to go 3 decimal places here. Negative 2.024. Okay. So negative 2.024. And the other one everybody agrees is going to be the positive? Okay. So guys, just a real quick sort of idea now. Okay, before I even do anything else. Think about it this way. That's a rejection area. That's a rejection area. In the middle is going to be my fail to reject. Does that make sense? Okay, boom. You guys are making me so happy tonight. Okay, tell me. Okay, so very good. On the inverse key, right, 0.05, right, 0.025, right? And then the second number would have been our 38, the DF, right? So guys, again, just a real quick heads up, guys, the 83s doesn't have that in there, so I had to type in a little program, and that's why mine looks like this. And those of you who lend me your calculators today, yours looks like that también. But if you got the 84, you're already set up. Okay, so now let's do the same thing we did before, guys. We're gonna find our t value, okay? So look, I'm just gonna copy down my formula. And now let's go ahead and do a little plug and chug. All right, so let me think about what my x bar and what my s is and all that stuff here. Let me write those values down before I even start to plug in. What is my x bar in this case? Yeah, look what it says right here, guys. The sample mean and standard deviation are 6.7 and 0.35 respectively. So I know we're not in English class here, but when they say respectively, what they're saying is that the sample mean is going to be the 0.67, or the 6.7, I'm sorry. And then the S is going to be the, which one? 0.35, okay? All right, so let's write it right here, 6.7 minus 6.8 divided by 0.35 divided by the square root of our n. Our n was 39? Okay. So, let me grab my calculator, clear it out. 6.7 minus 6.8 is negative 0.1 divided by parentheses. Let's take a look. 0.35 divided by the square root of 39. Close them twice. And I'm coming up with a negative 1.782 or 784. Okay. Negative 1.784. Okay. So guys, now that we have that part, everybody, we're still on the same page? Okay. Guys, where would that number fall? Would that number fall? Everybody agree that that number is going to fall somewhere in this region here? Right? Because we're going to be between those two numbers. Okay. So what we're going to say now is we're going to fail to reject. The null. Okay. I'm failing to reject the null. And guys, which one was my claim? The HO or the HA? The HO. Since that was my claim, right? Here's my claim is the O, is the HO, and we failed to reject it. What are we going to say? There you go. There is not enough evidence to reject the claim. Okay. Does this one seem easier? Okay, you know what it is, guys? It's the same exact problems. It's just that we've done more of them. Okay, because let me ask you a question. When we did right here, isn't that the same calculation we've been doing before? All it is, guys, we've just had a little bit more practice, okay? We've just had a little bit more practice. Now, I want to say, if you scroll down a little bit, isn't there a way to do this on the calculator? Oh, man, sir, why didn't you just get to this point to begin with? Okay, guys, the reason why I'm trying to show you this part here is because I want you to sort of have this understanding of what did we do right now, right? When we came up with our number and we came up with our negative 1.784, our question was, where does that number fall on this line right here, right? Does it fall this way? Does it fall that way? Or does it fall somewhere in the middle, right? And we were able to kind of figure that out, okay? So, give me a flavor. Let's take a look right here. Okay. So guys, if you notice what I have right here, same pieces of information for the problem we just did. So, give me a flavor, take your calculator, clear it all out, go to stat, go over to tests. We're going to go to the t-test, okay? All right, we're going to go to stats, okay? Now, let's take a look here. what is the mean that's being claimed? Or what's the mean in this case? 6.8. Okay, 6.8. Okay. Our x bar, what was our x bar in this case? 6.7. Okay, there we go. What was our s? 0.35. Okay. What was our n in this case? Do we know? 39? Okay, n was 39. There it is. Okay, now my question to you, left tail, right tail, two tail? Two tail. So look at the first one, guys, where it says not equal to. That's going to be my two tail. And then I'm going to go to calculate. I'll go like this. Hit calculate and then hit enter after that. Okay, let me ask you a question. Negative 1.784? Isn't that part right there? Okay, guys, what the calculator did for me, didn't it really just compute that number? Right? That's in essence what, I mean, it did some other things, but isn't that, in terms of what we did right here, isn't that what it did for me? Okay, let me ask you a question. Did the calculator right now, when we did our t-test, did the calculator tell me this number here and that number there? No. Okay, so the only thing that the calculator really did, guys, out of everything that we just did right now, all the calculator did was that calculation. Right? Was it that big of a deal? No, not really. It wasn't that big of a deal to do it, right? But that's what the calculator basically did for me, right? And that's the same thing that the calculator did for me on Tuesday night as well. It's just that, quick question, guys. How many of you have ever seen any of this stuff before? Never, right? Think about the first time you do something. Anybody here have children? Okay, some of us do, some of us don't. When your children were first learning how to go, they were, little, and you lay them down on the floor and they're on their back and they try to rotate to the panza. How long does it take for them to figure that out? So it figures out a while, right? And then they get to the panza. And how long does it take before they get up and they learn to crawl? How many of you had kids when they crawl, instead of crawling forward, they crawl backwards, right? Some of you had that? Okay. Think of how long it took, right? And I'm not trying to say that we're like babies or anything, but think about how long it took for us to, all of us, because we were all in that same boat at one point. All of us took so long to figure those things out, right? The first time we see something, man, totally out of this, right? I've never seen this before. And guys, this class is not like your typical algebra class. Like if I asked you, can you solve x plus 5 equals 12? Most of you could probably do that without too much thought, because that's what they sort of hammered into us all throughout high school and stuff like that, right? You know, it's not that bad now, right? But again, the first time we did it, it was like, oh man, it was horrible, right? Same kind of thing here, guys. The calculator really, all it did for me was that piece right there. Okay? All right, so anywho, guys, that's 7.3. Let me